Hello, everyone. Welcome to this exciting journey into the world of light, one of the most fascinating chapters in our grade 8 science curriculum. Have you ever wondered how we see things around us, or why shadows form, or how mirrors reflect images? And all of these everyday experiences are connected to the science of light. In this chapter, we will explore the core concepts of light, understand how it travels, how it interacts with different surfaces, and how it helps us see the world. We will also learn about important terms like reflection, refraction, luminous and non luminous objects, and much more. So, get ready to discover the magic of light and how it plays a vital role in our daily lives. Have you ever wondered how we are able to see things around us? Yes. An object becomes visible when light from that object enters our eyes. This light can either be emitted, like from the sun or a bulb, or reflected, like from a book or a wall. For example, imagine you are in a dark room with your friend. You won't be able to see them until someone switches on the light. That is because light reflects off your friend and enters your eyes, making them visible. So, light is the key that unlocks our ability to see the world around us. Okay, let's talk about something shiny, the reflection of light. So, what happens when light hits a surface and decides to bounce back like a basketball off the floor? That is called reflection. Now, meet our two ray buddies. Incident ray, this is a brave ray that goes in first and hits the surface. Reflected ray, this is a ray that says, nope, I am out here, and bounces back. Here is a cool example. You ever looked into a mirror and thought, wow, I look amazing today? That is reflection in action. Light from your face hits the mirror, reflects back, and boom, you see yourself. So, next time you admire your reflection, thank the science of light for making it possible. All right, science detectives, let's crack the laws of reflection. Law number one, the angle of incidence equals the angle of reflection. In simple words, light plays fair. If it comes in at a certain angle, it bounces off at the same angle, like a super disciplined boomerang. Law number two, the incident ray, the reflected ray, and the normal. Wait, what is a normal? It's just an imaginary line standing straight up from the surface. These three all lie in the same plane. Think of them as three best friends walking on the same floor. No one is flying off or digging underground. Here is a fun example. Shine a torch at a mirror. The light doesn't go wild. It reflects neatly at the same angle, just like a ball bouncing off a wall. Science loves symmetry. So next time you bounce a ball or flash a light, remember light follows rules too. Why can't we see anything in a completely dark room? Imagine walking into a pitch dark room. No lights, no glow, just darkness. Why can't we see anything? Because visibility needs light. Without light bouncing off objects and entering our eyes, it's like trying to read a book with your eyes closed. Not gonna happen. Question number two, why do we see ourselves in a mirror but not in a wall? Here is a fun one. Mirrors are smooth and shiny. They reflect light in a neat, organized way, like a well trained dance troupe. Walls, on the other hand, are rough and scatter light all over the place, like a messy party. That's why mirrors show your reflection and walls just show paint. Why do car headlights have shiny reflectors behind the bulb? Imagine a torch with superpowers. The shiny reflector behind the bulb helps bounce the light forward, making it brighter and more focused. That is called directional reflection, perfect for lighting up the road at night. And question number two, why do we wear white clothes in summer? White clouds are like cool superheroes. They reflect most of the sunlight instead of absorbing it. That means less heat and more chill. So, yes, science says white is the new cool. Question number three, why do shadows form? Here is the shadow secret. Light always travels in a straight line. When something blocks it, bam, a shadow appears behind the object. It's like light saying, oops, can't go through that. Let's meet the superstar of the light chapter, the ray of light. A ray is like an ideal straight line that shows us the path light travels. But in real life, light moves as a narrow beam made of many tiny loops. Think of it like a laser pointer. It shoots out a sharp beam that behaves just like a single ray. Now let's talk about the incident ray. This is a ray that boldly goes and strikes the surface like a torch beam hitting a mirror. It is the first one to make contact, kind of like the hero entering the scene. So, next time you shine a light and see it bounce, remember you have just witnessed the journey of a ray and its incident moment. Let's continue our light adventure with two more important characters, reflected ray and normal. First up, the reflected ray. This is the ray that says, I'm out here after hitting a surface. It bounces off and travels away like light doing a cool backflip of a mirror. For example, when you shine a torch on a mirror, the light that bounces back is the reflected ray. Now, meet the normal. Not your average ray, but an imaginary line drawn straight up, perpendicular to the surface at the point where light hits. It is super helpful in experiments because it helps us measure angles and understand how light behaves. Think of it as a referee in a light match, keeping everything in line. Let's go get into some light geometry. Don't worry, it's cooler than it sounds. First up, the angle of incidence. This is the angle between the incident ray, the one that hits the surface, and the normal, which is that imaginary referee line standing straight up. So, if you shine a torch at a mirror at a slant, the angle between the beam and the normal is called angle of incidence. Now, for the angle of reflection, this is the angle between the reflected ray and the normal. And here is the golden rule of light. Angle of incidence is equal to angle of reflection. That is the law of reflection. Light always bounces off at the same angle it came in. It's like playing ping pong with perfect aim. Here are some real life practical questions and examples. Question number one, why do we see ourselves clearly in a mirror but not in a wall? Let's play spot the reflection. A mirror has a super smooth surface that reflects light in a neat and organized way like a well behaved classroom. But a wall, it's rough and messy, it scatters light in all directions, so no clear image forms. So, next time you're brushing your hair, thank your bathroom mirror, not the wall. Question number two. Why do car headlights have reflectors? Ever noticed those shiny balls behind car bulbs? They are not just for decoration. They use the law of reflection to direct light forward, helping drivers see better at night. It's like giving the light a GPS. Go straight ahead. Question number three. What happens when sunlight hits a shiny spoon? You ever looked into a spoon and seen your face looking all squeezed and stretched? That is because the spoon acts like a curved mirror. It reflects light, but the curved surface distorts the image like a funhouse mirror at a carnival. Question number four. Why do shadows form behind objects? Here is a shadow mystery solved. Light travels in straight lines. When something blocks it, like you're standing under a street light, it can't go through. So, a dark area forms behind you. That is your shadow saying, hey, I'm here because light got blocked. Question number five. What happens if light hits the mirror along the normal? This one is cool and simple. If light hits the mirror straight on, along the normal, it reflects right back along the same path. It's like a laser beam doing a perfect U-turn. Let's wrap up our journey into the world of light with a quick recap. Here are the key concepts. Number one, light travels in straight lines, no curves, no shortcuts. Second point number two, a ray is a simplified model that shows the path of light. Point number three, reflection happens when light hits a surface and bounces back. Now, the laws of reflection are law number one, the angle of incidence is equals the angle of reflection, that is, angle of I is equals to angle of R. For second law is the incident ray, the reflected ray, and the normal all lie in the same plane, like teammates on the same field. And that's the magic of light. Simple rules, powerful effects. Let's bring light to life with some cool activities and real world uses. Activity 16.1, which is given in your textbook, kindly refer the textbook and read the activity once. Now I will explain to you in a very simple way. Uh, Grab a comb, a torch, and a mirror. Shine the torch through the comb and watch how light reflects signs in action. And next activity is 16.2. Try bending a shiny surface and see how the reflection changes. It's like giving light a twisty slide. Now, for some real life applications, mirrors in your home, periscopes in submarines, car headlights for night driving, solar cookers that use sunlight to cook food, laser alignment tools used in construction and surgeries. And here is a fun fact to light up your day. If you shine a laser at a mirror at a perfect 90 degrees, it comes straight back like a boomerang made of light. And that brings us to the end of our bright and brilliant journey into the world of refraction of light. We have learned how light travels in straight lines, how rays help us understand its path, and how reflection lets us see the world around us from mirrors to headlights and even laser beams. We explored the laws of reflection, saw how smooth and rough surfaces behave differently, and discovered how light plays a role in everyday things like shadows, spoons, and summer clothes. Through fun activities and real life examples, we saw that science isn't just in textbooks, it's all around us. So, next time you look in the mirror or see your shadow, remember you're witnessing the magic of light in action. And that's it, children. Thank you so much for watching my video. Kindly subscribe my channel and follow us in the Information Nest YouTube channel also. And always remember that after listening to videos, whatever videos and audios you are listening, after that, kindly read your textbook at least 3 times in a very calm and composed mind. Definitely, you will get clarification by reading the textbook. Thank you once again. See you in the next video. Bye bye. Signing off. This is Yamuna.